So welcome to the lecture number 5 of chapter 7. In lecture number 4 we have discussed about another criteria of congruency of triangle, that is known as ASA congruency. Okay, so according to the ASA congruency, if there are two triangles ABC and DEF, if any two angles, suppose this angle is equal to this angle and this angle is equal to this angle, and the included side, if this side is equal to this side, then these two triangles will become congruent. This is all about ASA congruency. These two are angles and this is the included side. Okay, so this is also known as theorem number 7.1. And we have discussed about this theorem in lecture number 4. In the lecture number 4, we have discussed that while proving this statement, that these two triangles will be congruent, there will be three conditions. What are the three conditions? The three conditions are that the first condition is maybe this side is equal to this side, AB is equal to D. This must be first conditions. The second condition is that either this distance or this side's length is greater than this side's length, AB is greater than D, or another case is maybe this length, this AB is less than D. There may be a chance. So AB is less than D. So we have to prove that these two triangles will be congruent under such conditions, and we have proved for the first two conditions in the lecture number 4. Okay, and in this lecture, in this session, we are going to discuss about these conditions. So our question will be same. Okay, this is the theorem number 7.2. Sorry, this is theorem number 7.1. I'm very sorry. This is the theorem number 7.1. Don't be confused. Okay, so now we will discuss about whether these two triangles will be congruent under the condition that AB is less than D. Okay, so let us prove. One thing you should keep in mind, that the proof for this condition is equal to the proof for the condition number 2. They are absolutely equal. We will follow the same procedure here also. Okay. So, since it is given that this distance is smaller than this distance, if it is 5 centimeter, then no doubt this will be more than 5 centimeter. It may be 6, it may be 7, it may be 8. Okay, so now we will prove that this two triangle will be congruent. How? Let's see. For this, we need to construct something. So what is the construction here? We need to construct as like the condition 2. Since this is less than this, then we have to choose a point P on DE so that this distance is equal to this distance. Again, I am telling you, we have to take a point P on the side DE so that this distance is equal to this distance. Clear? This is 8. Since this distance is equal to this distance, it means this distance is 5. Okay, so let us construct. So take a point P on DE so that this distance is equal to this distance. Okay, this is clear? And then what we will do? Then we have to join P and F and join PF. Okay, since it is already constructed that this distance is equal to this distance. Okay, now what we will do? Now we have to compare among the triangles ABC and the small triangle PEF. Okay, we will compare these two triangles, not the larger triangle. No, this is the smaller triangle with this triangle. Okay, now between triangle ABC and triangle PEF, this distance is equal to this distance because we constructed that this distance is equal to this distance. So AB is equal to PE. Why? By construction. Are you clear? Next, in this triangle, this angle is equal to this angle in this triangle, in this small triangle. Why? Because it is given B is equal to E. B is equal to E. It is given already. So we can write that B angle is equal to E angle. Why? Because it is given. Coming to the third condition. Third condition is that in this triangle, this base BC is equal to, in this triangle, this base EF. Reason is that it is given BC is equal to EF. It is given. So we can write that BC is equal to EF because it is given. Okay. So this stands for side, this stands for angle, this stands for side. Now you can see between the triangle ABC and the triangle PEF, this side is equal to this side is equal to this side, and the included angle is equal to the included angle. So by SAS criterion, this two triangle will be congruent. Okay, so we can write hence triangle ABC is congruent to the triangle PEF by SAS congruency. Up to this, I think you are all clear. Okay, we have proved that this triangle is congruent to this small triangle. Okay, but our target is not to prove that this is congruent to this triangle. No, this triangle is congruent to the last triangle. This is our target. Okay, so what we will do next? We will follow the same procedure as we have followed in the condition 2. What is that? Since we have found that this triangle is congruent to this triangle PEF, and we know according to the axiom 7.2, if in two triangle, if this two triangle will be congruent, then their corresponding angles will be congruent, will be equal, their corresponding sides will be equal. It means if this triangle is congruent to this triangle, then we can write that this angle is equal to this angle, this angle is equal to this angle, and this angle is equal to this angle. The corresponding angles will be equal. This is known as CPCT, corresponding parts of congruent triangles. Clear? So this is applied also here. So here we get that these two triangles are congruent. Forget about this line. Forget about this. You only consider this triangle and this triangle. And these two triangles are congruent. So according to the axiom number 7.2, we can write that this angle is equal to this angle. This angle. Because these are the corresponding angles of congruent triangles. So we can write SEB, this angle, is equal to this angle PFE by axiom 7.2. Suppose this is your equation number 1. Understood? Now draw the remaining parts. Next thing, but according to the given statement that C means this angle is equal to F. F means this angle, the total angle. It is given in this statement that this angle ACB is equal to the total angle DFE. Okay, it is given. Suppose it is equation number 2. Now you look at the equation 1 and equation 2. You can see here the left hand side is SCB, here also the left hand side is SCB. And we know if in two equations any two sides are equal, then we can write that the other sides, the alternate side must be equal. So we can write comparing equation 1 and 2, we can write that their right hand side must be equal. So we can write this angle is equal to this angle. This is our final result that we get by comparing these two equations. So what we get? We get DFE angle is equal to PFE angle. So what does it represent? See, DFE. DFE means DFE, the total angle. Okay, carefully look at this. PFE. PFE. That means this angle. This angle. So we proved that this total angle, this large angle is equal to this small angle. But if we look at this, we can see this is the larger angle. This is the smaller angle. Then how can they be equal? But we have proved already that they are equal. Okay? That means they will be equal if they follow a conditions. Okay? It is possible if they follow a conditions. What is that condition? The condition is that if we shift this side PF to this side to DF. Again I am telling you, if this is DF, this is PF. Okay? If we shift this side PF to DF, then what will happen? Then this PF will coincide on DF. Suppose this is your PF, this is your DF. Now this PF is shifted to DF so that this PF will lie on DF. If this lie on DF, then what will happen? Then this point P will shift to the point D. Now this point will become here. Okay? So we can say that point P and point D are not different points, they are the same point because the point P coincided on D. If P coincided on D, then this angle is equal to this angle. Okay? So this is possible when? This is possible if this is possible if this is possible if P is coincided on D. This is very most important point. If P is coincided on D. Coincided means P and D are the same point, they are not the different point. Okay? And one thing you have to think that if this point P coincided on D, then the distance from E to P is equal to the distance from E to D. Why? Because P and D are not the different point, they are the same point. So the distance of PE is equal to the distance of DE. Understood? So that we can write that the distance PE is equal to the distance DE. I have told you the reason. The reason is that P and D are the same point. So the distance from E to P is equal to the distance from E to D. Okay? But from the construction we know that this AB is equal to PE. See? We have already constructed, we have already initially taken that PE is equal to AB. It is 5. Then it will be 5. We have taken it initially. So, since we proved that PE is equal to D, but we have constructed that this PE is equal to, this is AB. So, we can write that PE is equal to AB. Are you getting this? Again, I am telling you that this PE is equal to AB. Why? Because we have already constructed that this distance is equal to this distance initially. This is. But here we have proved that whenever this P is substituted, is considered, is shifted to a point D, then the distance from PE is equal to the distance between DE. And this P is equal to AB. Okay? So this is the final clue that we need to prove that these two triangles will be congruent. This is the most important clue that we need. Now we can easily prove that these two triangles will be congruent. Okay, how? By comparing them. Let's compare. So, now between triangle ABC and triangle. Now this P can be erased. Why? Because P and D are the same point. So, ABC triangle and DEF triangle. Okay, so AB is equal to DF. We can write AB is equal to DF. Why AB is equal to DF? Because sorry, this is DE. By mistakenly I have written DF because we have proved that AB is equal to D. This distance is equal to this distance because this distance is nothing but the distance from P to E. Okay, so we can write AB is equal to D as we have already found it. Second thing, you can write by proved or by proving statement. Right. Second thing, in this triangle, this angle is equal to this angle. Why this angle is equal to this angle? Because it is given here. B is equal to E. It is given. So we can easily write that B is equal to E. It is given. Understood? Now coming to the third condition. Third condition is, in this triangle, this side BC is equal to, in this triangle, this side EF. Why? The reason is, it is given. BC is equal to EF. It is given. So we can write that BC is equal to EF because it is given. Okay, clear? So what do we get here? The three conditions are AB is equal to D, first condition. This angle is equal to this angle, second condition. This side is equal to this side, EF, third conditions. So by SAS criterion, this two triangle will be congruent now. Understood? Hence we can write the triangle ABC is congruent to the triangle DEF. Erase the point P. Okay? Hence we will find that the triangle ABC is congruent to the triangle DEF for the condition AB less than DE. Okay? It is now proved. Hence, we have completely proved the theorem number 7.1. And now, based on theorem number 7.1, we will solve a questions. Example number 3 from the NCERT. Okay? So, let us understand the statement. According to the question number 3, it is given that line segment AB is parallel to another line segment CD. Okay? So, from the statement, we have to draw the figure. Right? It is given that AB is parallel to another line CD. Suppose this is AB and this is CD. AB and CD. Since these two lines are parallel, so I write a symbol like this. And O is the midpoint of AD. AD means we have to join A and D. Now O is the midpoint of this line AD. Understood? Now from the following data we have to prove these two statements, that the triangle AOB, in order to find the triangle we have to join O and B and join O and C. That means we have to join BOC. Simple. Understood? And have to prove O is the midpoint of BC and this O is the midpoint of the line BC. We have to prove. Okay? So let us prove the first statement. Let us first analyze the data that are given. It is given that this line and this line are parallel. Okay? And AD is the line, O is the midpoint of AD. This is given. Okay? From this data we have to prove these two statements. Okay? Since, for the first proof, since AB is parallel to CD, it is given, and AD is a transversal line. Now remind the chapter number 6. We know if there are two parallel lines and a transversal line like this, these are two parallel lines and transversal line like this, then this angle is equal to this angle. Why? Because they are known as alternate interior angles. We know the pair of alternate interior angles will be equal. So if these are two parallel lines and this is the transversal line, then we can write that this angle is equal to this angle. This angle. Understood? So we can write that this angle means BAO is equal to this angle CDO. Clear? Why? Because they are alternate interior angles. So now we will prove that this triangle AOB is congruent to the triangle DC or DOC. Okay. So let us compare these two triangles. Between triangle AOB, write them in proper order. Okay. And triangle DOC. AOB, DOC. Okay. Since this angle is equal to this angle, because it is already given, these are two alternate interior angles, so you can write angle A or BAO is equal to CDO. Why? Because it is given, or because they are alternate interior. Second condition, since it is given that O is the midpoint of AD. If O is the midpoint of AD, suppose this is your AD and O is the midpoint, then what we can write? We can write that this distance AO is equal to this distance DO. If it is 10 centimeter and O is the midpoint, then this will be 5, this will be 5. Since O is the midpoint of AD, that means AO is equal to DO. Okay? So AO is equal to DO. Why? Because O is the midpoint of AD. It is given already. It is already given that O is the midpoint. So from this statement you have to conclude this statement. Okay? So next condition. In this triangle, this angle is equal to, in this triangles, this angles. Why? Tell me why these two angles will be equal? Because they are vertically opposite angle. Whenever this line and this line cross each other, intersect each other, then the pair of opposite angles are known as vertically opposite angles, and the vertical opposite angles will be equal. So we can write AOB is equal to which angle? AOB is equal to COD. Sorry, DOC, not COD, DOC, right, in proper order. Okay, AOB is equal to DOC because A is a vertex where this angle is related. Now D is a vertex where this angle is related. So AOB angle is equal to DOC angle. Now this stands for angle, this stands for side, this stands for angle. So since in this triangle and in this triangle, this angle is equal to this angle is equal to this angle, and this side is equal to this side, because O is the midpoint. So by angle side angle criterion, this two triangle will be congruent. Hence we can write that the triangle AOB is congruent to the triangle DOC. By which congruency? By angle side angle congruency. It is now proved. Clear? It is proved. Hence we prove the first statement. AOB triangle is congruent to DOC triangle. It is now proved. Okay. Next, coming to the second statement. Right. So let us prove the second statement. Since from the first statement we have proved that this triangle AOB is congruent to the triangle DOC. We have already proved this statement. And we know according to the axiom 7.2, if the two triangles will be congruent, then their corresponding angles are equal, corresponding sides also equal. For example, if this triangle and this triangle are congruent, then we can say this side is equal to this side is equal to this side is equal to this side. These are known as CPCT, corresponding parts of congruent triangles. Okay, since here these two triangles are congruent, so we can write that this side OB is equal to this side OC. Why? Because these are the congruent parts. These are the corresponding parts of these two congruent triangles. So it is OB is equal to OC by axiom 7.2. So OB is equal to OC means what? This is a line, this is O, this is B, this is C. It is given that OB is equal to OC. That means O is the midpoint of BC. If it is 5, it is 5, and the total length is 10. So we can say that O is the midpoint of BC. Clear? Hence we can write that O is the midpoint of BC. Understood? And this is the proof for the second statement. Hence it is proved. Clear?